Your neural network is learning nothing. Weights are updating, loss is dropping, but the model is basically dead. The culprit? A bad activation function. Today we fix that with ReLU. Neural networks are just stacked linear equations, but the real world is not linear. No matter how many layers you add, they all collapse into one linear transformation. Activation functions inject nonlinearity, the secret ingredient that lets networks learn curves, edges, faces, and language. ReLU stands for Rectified Linear Unit. The formula is almost insultingly simple. F of x equals the max of 0 and x. That's it. If the input is positive, pass it through unchanged. If it's negative, kill it. Output 0. Positive pass, negative 0. On a graph, ReLU looks like a hockey stick. Everything left of 0 is flat, a dead zone. Everything right is a diagonal with slope 1. That single kink at the origin, that's what gives the entire network its nonlinearity. The old default was Sigmoid. It squishes everything between 0 and 1. Sounds fine, but it destroys gradients. During backprop, tiny gradients get multiplied layer after layer until they vanish. ReLU has a gradient of exactly 1 for all positive inputs. No squishing, no vanishing. Early layers actually learn. ReLU isn't perfect, though. If a neuron's input is always negative, from bad weight in it or a large learning rate, it always outputs 0. Gradient is 0. It never updates. This is called a dead neuron. The fix? Leaky ReLU. Instead of 0 for negative inputs, give them a tiny slope of 0.01. The neuron stays alive. ReLU is the default activation in almost every modern deep learning architecture. ResNets, VGGs, transformer feed-forward layers. Fast to compute, sparse, powerful. Next time you build a hidden layer, just use ReLU, and your network will actually learn.